Remember this awesome game that Nokia had offered to its users in the early 2000s? In this game, a food is randomly generated on the screen so that the snake can grab the food. The main concept of this game is that whenever the snake reaches for the food, it increases in length. While approaching for the food, the snake has to bend its body several times, and if the head of the snake somehow touches its tail, the game is concluded. The score is generated depending on the number of food the snake has eaten. Our project is to recreate this game using various components used in digital logic designing process. Now let us move towards our design. Here we have used a simple 8 by 8 LED dot matrix to show the movement of the snake. Here the length of the snake is represented by the number of bits propagating on the screen. Since we have used simple logic design techniques and have not used any kind of microcontroller, it is not possible for us to bend the body of the snake at perfect 90-degree angle. But our snake can increase in length whenever it reaches for the food, and it can move towards any direction. Now let us move towards details. Now let us take a closer look at the length increasing blocks. This is our length increasing block for 1-bit propagation. Now if I simulate the Proteus file, then 1-bit propagation can be seen at the outlet. For designing this 1-bit propagation length block, we have used a 74193 counter IC and a 74238 decoder IC. Similarly, this is the length increasing block for 2-bit propagation. At the outlet, we can see propagation of 2 bits. For designing this block, we have mainly used 74273 shift register IC and some XOR gates and gates. The designing of 3-bit propagation length block is almost similar to that of 2-bit propagation length block. For this designing also, we have used 74273 shift register IC, and at the outlet we can see the propagation of 3 bits. And similarly, this one is the 4-bit propagation length block. And this one is the 5-bit propagation length block. Now let us move towards the second portion of the circuit. This one is our memory storage unit. Whenever we change the direction of the snake, this unit stores the memory of the previous propagating direction. For example, if the snake is propagating along the rows of the dot matrix and then we switch the direction so that the snake can move along column of the dot matrix, then this memory unit will store the last bit number, that is the bit number at which the head of the snake was while moving towards the row direction. In simple words, the memory unit stores the most significant bit towards the previous direction. That's why in this memory storage unit we have used a 74273 IC to store the memory of the previous direction. Now let us move towards the third portion of the circuit, that is the randomizer of the design. In this randomizer we have used two types of clocks. This clock gives us 20-second pulse, and after every 20 seconds the food can change by itself. So this clock is used to change the food by itself, so it randomizes the food basically. And this clock gives us 1-second pulse. As we can see that this clock is connected to the input of this AND gate, and the other input of this AND gate comes from this counter IC. This counter IC basically records the number of times the snake has eaten the food, that is, the length of the snake has increased. So the output of this counter IC gives us a score of the number of times the snake has eaten the food, and this counter IC gives us the number of times the food has changed by itself. And in this circuit we have also used some encoder, that is 4532 IC, and a decoder 238 IC, and a shift register 74273 IC. So this is our whole randomizer unit. Now let us move towards the final portion of our design, that is the switching module. Now in this Proteus file we have used a 74238 decoder for switching the direction of the snake. As we know that a decoder can take two input binary number and it can give us a 4-bit binary number as output. So as input we will give a 2-bit binary number to the decoder. So this 2-bit binary number actually represents the direction of the snake. For example, 00 will move the snake towards right direction, 01 will move the snake towards down direction, 10 will move the snake towards up direction, and the 11 will move the snake towards right left direction. So in this switching module we had only used a decoder. And finally, when we have our um, movement dot matrix and our randomizer dot matrix prepared, then we will take input from these two dot matrices and accumulate the results of those two dot matrices into one dot matrix. This process is basically known as scanning process, in which we can show the elements of two dot matrices in one single dot matrix. For that we had to use a very high frequency clock which gives us 60 Hertz frequency. Now let us move towards the final game. Now let us look at the score of the game. So the snake has eaten the food for 5 times because binary 101 represents 5, and the food has changed its location by itself for 4 times. So the user is the winner because he has eaten the food more times.